Hi guys. So for today's lesson, we're going to be working with some 3D problems to do with Pythagoras theorem. So there's one particular problem that I want you to think about that at first glance may not appear like it needs Pythagoras' theorem, but it definitely does. So the idea is, what is the length of the longest diagonal in a rectangular prism that's in this case measuring 5 centimeters by 7 centimeters by 8 centimeters? Okay, so we've got to think to ourselves, what would be the longest diagonal? Another way to think about it, what would be sort of like the longest stick or the longest pen or pencil or something that you could fit in this box? So the way that you would think about it, well, you'd have to kind of use a little bit of common sense here and realize that the longest pencil would be able to fit from, say, this corner right here all the way over to this far corner over here. So we got to figure out what is the length from that red dot all the way to this red dot. So how would we figure out that length? Well, the way that you would do it is you'd pretty much, you could draw that line in. So you could pretty much put that line in. They've put some letters here to pretty much show you which sort of lines we're meaning. So the longest diagonal is from E to C. These letters help because they pretty much just tell you exactly what sort of line we're talking about. So the longest one would be, say, from E to C. That would be the same as, say, from G to A. But let's just use C to E for now. Okay, so how do we find this longest diagonal? So what we need to do is we need to realize that this longest diagonal, we need to figure out what sort of triangle, and in particular right-angled triangle, is this line EC a part of. So I want you to realize that this line EC is a part of this triangle right here. Now this triangle is like within our box. It's on the inside. It's definitely not on the outside of this box. Sorry guys. So just fix up a few things. Okay, so we got to figure out how do we find this length. Well, it's a part of this triangle here. And I want you to notice that this triangle is definitely a right angle triangle, because this line along here, the bottom, that's definitely flat, and that line there is definitely pointing straight up into the air. So they're going to be at right angles. It's really important to know that that's a right angle triangle, because you can only apply Pythagoras' theorem to right angle triangles. Okay, so if we want to find this length EC, we can use Pythagoras if we know this length here and if we also know this length here. Okay, so we've got to think to ourselves, how do we figure out, the way to figure out this one is to know this one and this one. So we've got to think to ourselves, well, we know this length here, but we don't know this one here, and that's a problem. We need to know both of those to use Pythagoras for that. Okay, so our aim is to figure out this one here, because that's our missing piece of information. What is the length of this diagonal? Well, the way to find this length AC is to realize that it's part of this triangle down here. Now, this triangle is also going to be a right angle triangle. And the reason for that is because this line is lying flat on the ground, and this line here and this line here, they're just part of the square or the rectangle that's lying on the bottom. And rectangles on the bottom, rectangles always have 90-degree angles. So therefore, in the corners, so therefore that must be a right angle. So therefore, what we can do is we can apply Pythagoras' theorem to this red triangle on the bottom, and that will give us our length for A to C. So we know that that's 5 centimeters and we know that that's 7 centimeters. So we use A squared plus B squared equals C squared for the 5 and the 7. And that looks something along the lines of this. So 5 squared and 7 squared to find our AC from A to C. Okay, and then 5 squared plus 7 squared equals 25 plus our 49. and so a squared equals 74. So therefore AC equals the square root of this, which is going to be about 8.60 to 2 decimal places. Okay, so now that we know AC, so A to C is 8.60, we can use this length that we found, AC, we can use it to figure out our longest diagonal in our box from C to E. Okay, so in Pythagoras' theorem, we're going to want to use this length here, and we're going to use our newly found AC. So putting that into our calculator, so we've got CE, so that's what we're trying to find, square that side, and it's equal to AE squared plus AC squared, because we see our right angle triangle there. So here we've got 8 squared for AE, because we've got our 8 here. We've got 74 here. Now the reason we've got that is because we know what AC squared was. We figured out AC squared to be 74. We don't want to use this number because that is rounded. We don't want to use a rounded answer too early. So use the 74 instead. That's what AC squared is. Okay, so AC squared is 74. And we get that 8 squared equals 64. And so CE squared ends up being 138. So there CE is the square root of this number. And that equals 11.75. So that's roughly the length of this longest diagonal in our box. So that is a typical sort of three-dimensional question where we can apply Pythagoras' theorem. So if I move along, I was looking at this this PowerPoint, and I thought this question was quite interesting. So if you look at a box that's like this, so it's like a triangular prism, what would be the longest pencil that you could fit inside this sort of box? To tell you the truth, I'm yet to really figure out the answer here. I think the answer would be, I think the longest pencil you could fit in here would be from this point here to this point here. That's just my kind of hunch, but I could easily be wrong. And if that was the case, well, you can see that all I would need to do is figure out that length, and I already know that length is 18 centimeters. So I'd have to find out what this length is here, and then I can use Pythagoras on this right angled triangle, which I see here. So the way that I'd figure out that length is I would use the fact that that is 4 centimeters, and I'd use the fact that that is 2 centimeters because it's half of this 4. So I would use 4 cm there, and I would use 2 centimeters there. I would use Pythagoras to find this length, and then I can use that length and that length to find out my longest pencil. Hopefully this helps you out with some of the questions. Good luck.